Let us start our example number 1. Find out the proportions of concrete for the following data. As we know, based on the requirement of our existing site and the properties of the ingredients like cement type, coarse aggregate, fine aggregate and water mass, and based on the plasticizer as well as the super plasticizer, we have to find out the particular compressive strength. In short, we have to calculate the compressive strength of the concrete mass at the end of the 28 days. Here I am taking a particular type of the concrete mass. It means a requirement for the particular one site and with the properties of the ingredients. So after this data, you have to find out the characteristic strength of the compressive strength at the 28 days. It means you have to do the mixed design for particular type of the concrete with the properties of the all the ingredients of the concrete mass. Here you can see you have to take the M25 grade of the concrete mass. We will do mixed design for the M25 of the concrete. And degree of control, which is very good. Maximum size of aggregate is 10 mm. Specific gravity of cement is 3.15. Specific gravity of fine aggregate is 2.70. Specific gravity of coarse aggregate is 2.82. Condition of exposure is severe. Workability of concrete with the slump value 75 to 100 mm, and you have to assume the remaining data as per the Indian standard. Here you can see our requirement of the existing site, which is M25, and here you can see the conditions and properties of the ingredients has been given in this data. So these are the properties of the ingredients like specific gravities of the cement, specific gravities of the fine aggregate, coarse aggregate, slump value. So based on this data and the requirement of the existing site, you have to do mixed design and you have to finalize the proportions of the all the ingredients of the concrete mass. Let us start with first step, which is target mean strength of the concrete. So as we know, the F dash CK is equal to FCK plus 1.65 S. What is S? S means standard deviation, and F dash CK is equal to target mean strength, and FCK, which is our compressive strength at the 28 days. So finding the target mean strength of the concrete, F dash CK is equal to FCK, which is 25, because we are doing mixed design for the M25 grade of the concrete mass, plus 1.65 into S. S means standard deviation. So standard deviation based on the grade of the concrete mass. This value you can refer the table number 1, I is 10262-2009, and for the M25 grade of the concrete mass, you have to take the 4 Newton per mm square for the standard deviation. It means for the M25 grade of the concrete mass, the target mean strength is equal to 25 plus 1.65 into standard deviation value, which is 4, and then you can easily calculate 31.6 Newton per mm square of target mean strength of the concrete mass. So this is our first step of the Indian standard mixed design. So let us discuss about second step to finalize the water cement ratio. So based on the data, we have to take the severe condition and the severe condition, we have to take the water cement ratio 0.45, and you can refer this table. For the severe exposure condition, you can take 45 percentage water cement ratio for this condition. After the finalizing the maximum water cement ratio, you can take the water cement ratio based on the experience. Based on the experience, I am taking the water cement ratio 40 percentage. It means water cement ratio is equal to 0.4, and I am taking the least value above this 45 and 40 percentage. I am taking the 40 percentage of the water cement ratio. It means water cement ratio is equal to 0.4. After the finalizing the water cement ratio, our next step is to calculate the water content, and you can finalize the maximum water content based on the nominal maximum size of the aggregate. This table has been given in the Indian Standard 10262-2009 table 2, and you can use for the 10 mm nominal size of the aggregate maximum water content, you can take the 208 liter. For the 20 mm nominal maximum size of the aggregate, you can take 186 liter of maximum value for the water content, and for the 40 mm nominal size of the aggregate, you can take the maximum value 165 liter for the water mass. And as per our data, we are using the 10 mm size of the aggregate. It means we can use the maximum 208 liter in our concrete mix. And after this value, we have to correct this value for the slum range, because this table based on the 25 to 50 mm slum range of the workability, and based on our data we require 100 mm slum, and as we know every 25 mm slum we have to add 3 percentage of the water mass. So after the finalizing this value 208 liter, and these tables for the 25 to 50 mm slum range, and we are calculating the 100 mm slum cone, it means we have to add 3 percentage plus 3 percentage, because 50 plus 25 plus 25, it means we have to add the 6 percentage for the correction. You can see here the table shows the 25 to 50 mm slum 208 liters, and 25 to 75 mm slum we have to add 3 percentage of this value, and we are concreting the 100 mm slum. So 75 to 100 mm slum we have to add the 208 liter plus 3 percentage plus 3 percentage. It means we require 208 liter plus 6 percentage. So correction of water mass 208 liter, and we have to add 6 percentage. It means 208 multiplied by 106 divided by 100. It means we have a final water mass 220 liter. And as we know, we have to also require correction regarding the superplasticizer, and with using of the superplasticizer, the water can reduce the 20 percentage or above. For example, I am assuming the 18 percentage reduction in the water content due to the superplasticizer. It means our final water mass will be 220 multiplied by 82 divided by 100. It means I am taking 82% of the 22 liter. It means I am decreasing the 18 percentage of water mass due to the super plasticizer. In simple, you are calculating of the 82 percentage of this value. It means 220 multiplied by 82 divided by 100. It means your final value will be 180 liter. So this all about the calculation of the water content. Next step is calculation of cement content. After the finalizing the water cement ratio and water mass, we can easily calculate the cement content as we have taken the water cement ratio 0.4 and we have also calculated the water content which is 180 liter. So you can easily calculate the cement mass. It means our cement mass is 400 kilogram per meter cube. And you have to check the minimum criteria for the Indian standard. And as we know, the Indian standard 456-2000 table number 5 has been given to particular table for the minimum cement content with exposure condition of the concrete mass. For example, in the mild and moderate exposure condition, you have to take at least 300 kilogram per meter cube. In the severe condition, you have to take at least 320 kilogram per meter cube. And very extreme condition, at least you have to take 340 kilogram per meter cube. And in the extreme condition, you require minimum 360 kilogram per meter cube. So you have to check the minimum criteria based on the Indian standard. So our cement mass is 450 kilogram per meter cube, and based on our data we are concreting in the severe condition. You can see for the severe condition you require 320 kilogram per meter cube for minimum requirement, and we have taken 450 kilogram per meter cube. It means okay. So you have to take the greater value of calculation based on our previous data and Indian standard. Our next step is calculation of coarse aggregate and fine aggregate. Coarse aggregate and fine aggregate, which is dependent on the zone of fine aggregate. So we have to finalize the zone of the fine aggregate, and then we can easily calculate the volume of coarse aggregate, and then we can calculate the volume of fine aggregate. So in the data we have not given the zone for this mixed design, and I am consider the zone 2, but we are using the 10 mm size of the aggregate, and you can see the table which has been given in Indian standard 456-2000 table 5, and this table you can see in the first column shows that the nominal maximum size of the aggregate, and this column shows that the different zone for volume of coarse aggregate per unit of the total aggregate for the different zone of the fine aggregate. So these values are for the volume of coarse aggregate with different zone, and you have to take this value based on the nominal maximum size of the aggregate, and we are using the 10 mm size of aggregate. And based on this table, here we are using the 10 mm maximum nominal size of the aggregate, and we have considered the zone 2, and you can see on the table you have to take the volume 46% for the coarse aggregate, and the remaining portion for the fine aggregate. So we have to take the volume of coarse aggregate, which is 0.46, and the remaining portion for the volume of fine aggregate. And now we require correction for this volume. As we know, this table is used for the water cement ratio is 0.50, and we have taken the 0.40. It means we have taken 40% water cement ratio. So we have to correct this volume. And for the coarse aggregate, we have taken 0.46. It means we have taken the 46% of the coarse aggregate, but due to the water cement ratio we have to correct this volume, and this table shows that water cement ratio 0.50 and we have taken water cement ratio 0.40, but this difference will be 0.1. So we have to increase the 2% of the coarse aggregate. It means we have to take 0.46 plus 2%. It means we require 48% of the coarse aggregate after the correction, and remaining portion for the fine aggregate, which is 52%. So you have to calculate the coarse aggregate and fine aggregate with correction. After the finalizing the volume of coarse aggregate and fine aggregate, now our next step is calculation of mix proportion. As we know, we are calculating for the any mix design for the 1 meter cube, and we have taken 176 liter for water mass. So our volume of water will be 0.173 meter cube, and our cement volume will be 450 divided by 3.15 multiplied by, it means 450 kg, which is mass of the cement, and 3.15, which is the specific gravity of the cement mass, and we can easily calculate of cement volume by this equation. 450 kg divided by specific gravity multiplied by, and we can easily find out the volume of cement. It means 0.143 meter cube of cement volume. Then we have to also find out the chemical admixtures, and we have used the superplasticizer for water reducing. And I am assuming that I am using the 2% by the weight of the cement mass. So 2% by the weight of the cement means 2% of the 450 kg of the cement mass divided by 1.1, which is the specific gravity of the superplasticizer multiplied by, it means 450 multiplied by 0.2 divided by 1100. So we can easily calculate the volume of chemical admixture, which is 0.0082 meter cube. Now we have a volume of water 0.173, volume of cement 0.143, and volume of chemical admixture, which is 0.0082 meter cube. And with these values we can easily find out the volume of all aggregate. It means 1 minus 0.176 means volume of water, plus 0.143 means volume of cement, plus 0.0082, which is for admixture. It means you can understand that in our concrete mass we are using the water mass, next cement mass, admixtures, and remaining portion will be aggregates for fine aggregates and coarse aggregates. So total volume will be calculated by summation of aggregates volume of aggregates, volume of water, volume of cement and volume of admixtures. So if we want to find out the volume of aggregates, so we can calculate with this calculation means 1 minus volume of water, volume of cement, volume of superplasticizer. So remaining portion for the aggregates. So we have a 0.673 meter cube for aggregate volume, and as per the previous data we have taken 48 percentage for coarse aggregate of the total volume and remaining portion which is 52 percentage of the fine aggregate of the total volume. Then we can easily find out the mass of the coarse aggregate and fine aggregate. You can see the calculation for the mass of the coarse aggregate which is 0.673, which is total volume of aggregate, and 48 means you are taking the 48 percentage of the total volume, and 2.82 which is the specific gravity of the coarse aggregate, and you have to multiply 1000. It means you can calculate the mass of the coarse aggregate which is 911 kilogram. And after the calculation of the coarse aggregate, now we will move for the fine aggregate. Here you can see the calculation 0.673 which is the total volume of the aggregate, and we are using the 52 percentage of the total volume, and 2.70 which is the specific gravity of the fine aggregate, and multiply by 1000. It means now we have a 945 kilogram. So after the finalizing the volume of the all the ingredients, now we can finalize the proportion of the ingredients of the concrete mass. So our next step is mix proportions for trial number 1. So as we have taken cement mass as 450 kilogram per meter cube, water mass 176 liter, and we have taken the water cement ratio 176 divided by 450 which is 0.39, and after the calculation we have fine aggregate is 945 kilogram per meter cube and coarse aggregate is 911 kilogram per meter cube, and chemical admixture we have calculated 9 kilogram per meter cube, and our total weight density of concrete which is 2491 kilogram per meter cube. So our last step is finalizing the mix proportion which is 450 kilogram of the cement, and we have used water mass 176 liter, and we have used the fine aggregates 945 kilogram, and we have used the coarse aggregate 911 kilogram per meter cube. So these values based on the 450 kilogram of the cement mass. Now we can calculate this value based on the 1 kilogram. For the 450 kg of the cement mass we require 176 liter of the water. So for the 1 kilogram of the cement mass we will require 0.39 liter of the water mass, and 2.1 kg for the fine aggregate and 2.02 of coarse aggregate. So we can easily calculate based on the 1 kilogram, and we can easily find out based on the 50 kg because our cement bag is packed based on 50 kg. So we have to finalize our proportion based on the bag of the cement mass. It means we have to finalize based on the 50 kg of cement mass. So we can multiply this value with the 50. It means based on the 50 kg of the cement, our water mass requirement will be 19.5 liter, and fine aggregate will require 105 kg, and coarse aggregate will require 101 kg. So this proportion based on the 50 kg. So you can easily calculate with this data. And after the finalizing the proportion, you have to find out the hardened properties of the concrete mass, and you have to check the strength is adequate or not. If you are achieving your desired strength, it means your proportion is okay. This is the trial based method. So if you are not achieving the desired strength of the concrete mass, so you will require the more trials. Thank you.